last topic for MATLAB is plotting. So we're just going to go over essentially all the basics in which you can use in order to plot things, but it's really about finding the right function in order to make your plot. So we're going to focus on some functions. Specifically in this class, we'll focus on plot, fplot, semilog x, and semilog y. There's lots of other plotting functions that we can use. You can see them here in this table. But we're going to focus on just these ones for these 2D plots that are line graphs. Plot, semilog x, semilog y, all of these behave the same in terms of what their inputs to the functions are. Fplot's the only one that's a little bit different. Okay, so then it's just going through a bunch of functions and how we can do things. So figure, the figure function is used to open up a new figure window. Essentially, if we type figure or figure n, where n is a number, it will just open up a new figure window in order to have a plot on it. We can open up as many figure windows as we want. We can put multiple plots on the same figure window. But it's just essentially stating, okay, here is a figure that I am going to plot on. We can save this figure, we can copy, paste it, all that fun stuff. The close function closes all of our figure windows, so it would close that out, meaning we start with none. So we can close all of them, we can close a specific one, so close one, or close all. Once we have a figure window open, we can go ahead and plot on that figure window. So my first function is plot. The plot function will go ahead and create a set of axes on here and plot some data. If we just say plot y, it'll plot x as the index, so x is 1 through the length of y. We can also give it a specific x and y vector. So if x equals negative 50 to 50, it will go ahead and use those x values comparing these y values. Note to self, x and y need to have the same number of values. And we can also plot multiple data on the same set of axes. This would be my first xy, that's a mistake, it should say y1. This is my second set of data, and then third set of data, etc. So we can plot multiple data at the same time on one axis using one plot function. We can also use fplot. So fplot is used to create a line graph on axes by plotting a mathematical function. Essentially, this eliminates the need for creating separate vectors. This only works if y is a function of x. And the way it works is we say fplot at variable. This would be our independent variable, such as x or t, whatever it is, whatever goes in here. And then here is what we would calculate our function is. Calculate the function with array operations. So we would say, I don't know, x dot squared in order to plot y equals x squared. And then here we can put in our limits. So we can say, okay, plot the data between negative 10 and 10. We also have semilog y, semilog x, and log. These behave the same in terms of plot. They need an x-axis or x values and y values, x vector and y vector, but it just determines the scale on which our x and y axes are going to be. So semilog x plots x on a log. So log on the x-axis and linear on the y-axis. Semilog y plots log on the y-axis, linear on the x-axis, and log plots them both in a logarithmic axes. But they behave the same as plot. So it really just depends on whether or not you want log axes or not. If you want log axes, use one of these instead of plot. If you don't, use plot. Okay, so we can open up a new figure window. We can go ahead and plot some data on there. But let's say we want to plot data in the same figure window in different axes. That's where the subplot function comes in. So subplot is used to break up your figure window. So essentially, we would indicate how many rows and columns we want. So let's say I want to break this up into 2 rows, 3 columns. I would say subplot 2, 3. This is plot number 1, this is plot number 2, this is plot number 3, 4, 5, 6. I believe that's the case. It might go down the column, but I believe subplot goes by the row. So then we indicate which plot number we want to add data to. So let's say plot number 3. So I want to fill in this region with an axis. I would say subplot 2, 3, 3. And then below that, I would say plot x, y. So what that would do is that would go ahead, break this up into 2 rows, 3 columns, and in the third location, it would plot your x and y value in that location. If I wanted to say subplot 2, 3, 4, and then plot x, y, it would put one here. So that's how we can go ahead and put multiple sets of axes on the same figure window. The hold command is used to go ahead and plot data on the same set of axes. So if I have plot x, y, it would plot my data. But let's say I had more data later on. I can say hold on, and then plot x, y again, and it would plot my another set of data. So let's make it blue. Another set of data. And then if I did, so here's my blue set of data, and then if I did plot x, y again, it would plot another set of data, whatever that looks like, until I go ahead and say hold off. So that's what hold on is used for, is to plot multiple sets of data on the same axes. This would also, we could also do this using the same plot command. This being our first set of data, second set of data, third set of data. But it just depends on how your code is designed. Sometimes you don't have all of the data at the same time, so you can't use this one. Or sometimes you're using data that evolves over time, so you want to plot and see how it changes over time. So that's where we might use the hold on. Or if you're using multiple plot commands, like plot and fplot or scatter or something along those lines, that's where you can go ahead and use the hold on command. Okay, so that's all about plotting data. But now let's go ahead and talk about what if we want to change what the data looks like. So we can go ahead and change a couple properties about the way the data is plotted. We can change what the line looks like. We can change whether or not we have data markers indicating the line, and then we can indicate different colors. So first thing is line specifiers. So here's our line specifiers. Here it's 1 to 3 characters indicating these options down here. They immediately follow your data, so plot x, y, and then line specifiers. They go in quotes, and it's 1 to 3 characters. One of the characters can correspond, it doesn't have to. You don't have to do all 3 of these things, and it doesn't matter the order. But one of the characters corresponds to the type of line we want. So if we want a solid line, we would do a single dash. If we want a dash line, we do 2 dashes. Characters, I'll call them options. Not really characters, options. If we want a dotted line, we use a colon. If we want a dash dotted line, we use a dash dot. If we want to indicate that we want markers, here we can indicate which kind of symbol we want to use to indicate the marker. So if I want my markers to be plus signs, I would use a plus. If I want them to be circles, I'd do a circle, etc. And then here are our color options. There's not that many. MATLAB has more color options built in, but these are the ones that we can go ahead and modify without doing lots of more in-depth analysis or in-depth programming. So we can change it to a red color, a green color, a blue, cyan, magenta, yellow, black, white, essentially printer colors and RGB. Those become our color options. So if I said I wanted to plot x, y, in double quotes, I would say a dash line or a dotted line with square data markers that are yellow. That's what it looks like. I would say colon S, Y. Notice there's no overlap between these symbols, and these symbols. So this would be the same as saying S colon Y, or the same as saying Y S colon. Does not matter the order, because the Y automatically corresponds to the color, because it's the only other option, or the only option. S automatically corresponds to the marker, because it's the only option, and then colon automatically corresponds to the line style. So that's how we can go ahead and change those 3 options. We can also change the line width, the marker size, the marker edge color, and the marker face color using these additional properties. So these additional properties go after are line specifiers. We indicate which property name we want to change, double quotes, single quotes, doesn't matter, and then our property value. So if I want to change my line width, I can say plot x comma y. Let's say I have my dotted line that's square in yellow. I can say, okay, I'm going to change the line width. It's not case sensitive, so you can use either one. And I want to change it to 2. I would give it a 2. And then if I also want to change my marker edge color, these are my options, my color options. Let's say I wanted to change it to magenta. There we go. It would plot my data with a dotted line, with a square data markers, a yellow line. The line width would be 2, and it would change the marker edge color to magenta. And then if we want to change the marker size, we can change that. Marker face color, change that as well. But those are our options. So just some notation in terms of what a plot looks like. Here's an example of a plot. Here's a data line. So let's say we have some theoretical data. Here's our data line. If we have a function for that, maybe we can plot it with fplot. So fplot at x, looks like a function. Obviously it's not x squared, but we'll say it's x squared. And then my range is from 9 to 21. This data here then, my theoretical data, experimental data, let's say I plot x, y, I have some experimental data. It's a dashed line, it's orange. We will call it red. And I have circle data markers. And here my circle data markers are empty, so I wouldn't change the face color. It all matches. But here we can see the difference between how these two are plotted. The rest of the stuff on this plot is through these annotations. So here's different annotation functions that we can use. So title would add a title. So here's a title. X label would add an X label. Here's my X label. Here's my Y label. If I wanted a grid, I can use grid. There's no grid on here, but I can use grid on or off to turn the grid on and off. If I wanted to add text to my data in a specific location, I can use the text function. And then here I can go ahead and add in a legend. And then I can go ahead and modify the x-axes. So for this, I would say axis, the minimum x value up here on this plot is 8. The maximum x is 24. The minimum y is 0. And the max y is 1400. So I can use the axes function to go ahead and zoom out on my plot if I want to. And that's it when it comes to plotting. So let's go ahead and see all this in action. So I have some code over here that I wrote already and a figure that it creates. So here I have some data. Close means I just close all of my previously open figure windows. So close everything. Then I generate some data. So here's my data. I have an x vector, it goes from 50 to 70, it increments by 0.1. I have some y data, that's this calculation. And then I go ahead and here's my plot. Here's all my plotting code. So note, there's not a lot of code in here, not a lot of calculations. It's all pretty much to create this beautiful figure over on the right-hand side. Figure 1. This opens up this entire box. This creates figure 1. It's an empty space where I can go ahead and plot some data. Subplot 311 breaks it up into 3 regions. 3 rows, 1 column. So you can see how I broke it up. And then this 1 here indicates I'm going to talk about the first region. I'm plotting in this region. Plot XY goes ahead, creates this grid here, or this axis here, and plots my data. That's what plot XY does. Title here adds this title. X label adds the X label. Y label adds this Y label. Grid on puts this grid here on in the background. And then text. Text adds a text right here. Note, it's the X location, Y location. The X location is 52. The Y location is 5. It adds text here. That text is starting point. Just call it whatever I want. That's how I generate this plot right here. The second plot, the second one, subplot 312. That indicates I'm talking about this region here. Breaks it up into 3 rows, 1 column, and now I'm talking about the second region. F-plot looks like this. So F-plot at X. So note it doesn't use this data at all. It just at X, and then here's my same Y function that I did up here. But I don't need this data to do F-plot, so it's another option. And then I'm plotting on the range 50 to 70, because I want to match this data here. Then I add a title, so here's my title. Then I add an X label, Y label, same thing, add a grid, all of that stuff. So, my bad. Title, X label, Y label, grid, all that fun stuff. And then axis. So here's where I've modified the axes on this plot here to match this plot here. Because if I didn't do that, it wouldn't look the same. It wouldn't look the same. It wasn't quite at the same range. So I've gone ahead and I've said, okay, if I want my X range to go from 50 to 70, then I put a 50 and a 70. If I want my Y range to go from negative 30 to 20, I put a negative 30 and a 20. And I can modify my axis range. The last plot, subplot 3, 1, 3. That's this region here. Breaks it up into 3 rows, 1 column. And now I'm in the third area. Plot. Okay, so here's where I start to change what my figure or what my data looks like. Plot X, Y. Here, I'm just indicating I want it to be black. I did not give it what kind of line style. The default is solid. I did not give it a data marker type, which means I don't want data markers. I just said plot a black line. And that line width is going to be changed to 2. So note this black line here is thicker than these blue lines up here. I've changed it to 2. The default line width is 0.5. Then I say hold on. When I say hold on, that means I can go ahead and plot more data in this same set of axes. So I'm plotting now F-plot. So I've plotted them on the same graph. I'm plotting an F-plot. Here I'm plotting a magenta line or magenta data with a circle data marker. So you can zoom in and you can see these circles are magenta. And I've changed the marker face color to blue. So I'm changing this property and blue. So we can see here my data markers are magenta outlined with a blue face marker. And we can see the data essentially that's generated with F-plot. I've added a title, an X label, a Y label, a grid on, and here's my legend. So I'm doing my legend. I have 2 lines. My first line is from my first plot. So this is from the plot function. My second line is from F-plot, so there's my second line. If we had more lines, we would just add in more text to say whichever the next line that was plotted corresponds to this text, the next line that was plotted corresponds to this text. This here is optional to indicate where I want to put my legend. So I said location southwest, which means it's in the southwest quadrant of my graph. And that's optional. I'm just deciding where to put it. Otherwise, I don't know where I would put it. Maybe I'd put it over here, which there's data over there. In general, the default option of where it's placed is pretty nice. But here we can see, this is one way that we can plot this data. There's lots of options, but that's essentially how we go about plotting. Identifying what we want our data to look like, figuring out the function we're going to use in order to make it look like that.